Have you ever wondered what lies deep beneath the Earth's surface? It's not just layers upon layers of rock and magma. No, it's something far more fascinating. Within the deep recesses of our planet, beneath the tectonic plates of Africa and the Pacific Ocean, lie remnants of a celestial body, a planet named Theia. Yes, you heard it correctly, an entire planet. This isn't just any planet, but one that is believed to have collided with Earth about 4.5 billion years ago. Theia wasn't just a small meteorite. It was a Mars-sized planet. Imagine the impact of such a collision. It was so intense that Theia didn't just break apart, it disintegrated into hot lava fragments. Some of these fragments, as dense and massive as they were, found their way deep into the Earth's interior, where they remain to this day. But what about the rest? Where did the rest of Theia go after this cataclysmic event? This is a question that has long perplexed scientists. However, recent data from NASA's Gravity Recovery and Interior Laboratory, or GRAIL, has shed new light on this mystery. Beneath our moon's surface, large deposits of titanium iron ore were discovered. These deposits are believed to be the remaining fragments of Theia, suggesting that after the collision, Theia didn't just sink into the Earth. It also contributed to the formation of our moon. It's a revelation that redefines our understanding of our own planet and its celestial companion. But how did scientists manage to piece together this cosmic puzzle that occurred billions of years ago? So, how did scientists unravel this age-old mystery? Let's dive in. The story begins with an age-old theory, a catastrophic collision, and an elusive planet named Theia. This tale is not one of destruction, but of creation. The creation of our very own moon, as a matter of fact. Picture this. About 4.5 billion years ago, Theia, a Mars-sized planet, collided with Earth. The impact was so intense that Theia was sliced into hot lava fragments. Now, imagine these fragments of the ill-fated Theia. Some of them got buried deep beneath the Earth's crust, forming dense and massive blobs. These remnants of Theia are believed to be nestled underneath the tectonic plates of Africa and the Pacific Ocean. Think of these blobs as the hidden treasure of our planet, a buried secret that tells a tale of a time long gone by. But this is only half the story. Theia was a planet, after all, and a Mars-sized one at that. Surely the fragments that got buried under Earth's crust couldn't have been all of Theia, so the question that has been baffling scientists for years: where did the rest of Theia go after the collision? The answer to this question is not as straightforward as you might think. It requires us to look beyond our home planet, into the vast expanse of the cosmos. The answer, as it turns out, lies not on Earth, but on our very own moon. The moon, our closest celestial neighbor, holds secrets deep beneath its surface. This barren and seemingly silent celestial body has a story to tell, one that goes back about 4.5 billion years. It's a tale of cosmic catastrophe and rebirth, a celestial dance of destruction and creation. NASA's Gravity Recovery and Interior Laboratory, or GRAIL spacecraft, has been investigating these mysteries. As it weaved its way around the moon, GRAIL's sensors detected large deposits of titanium iron ore deep beneath the moon's surface. This isn't just any titanium iron ore, we're talking about a specific type called ilmenite. This mineral is not commonly found on Earth, but it's abundant on the moon. Now, here's where the plot thickens. These large deposits of ilmenite could be the missing pieces of the puzzle, the remnants of the long-lost planet, Theia. Yes, you heard it right, a planet that existed 4.5 billion years ago, a planet believed to have collided with Earth, a planet whose fragments might just be lying beneath the surface of our own moon. After the colossal collision, the theory goes, Theia was shattered into fragments. Some of these fragments ended up on Earth, buried deep beneath our oceans and continents. But what about the rest of Theia? Well, as the dust settled and the fragments cooled, they could have coalesced to form the moon we see in our night sky. The ilmenite deposits detected by GRAIL could be the remnants of Theia, a ghostly echo from an ancient cosmic collision. As they sank towards the moon's core, they displaced lighter rock, pushing it upwards and creating the moon's crust. Each night, as we gaze at the moon, we might just be staring at the vestiges of a long-lost world, a planet that sacrificed itself to give birth to the moon and shape the Earth as we know it. But how certain can we be that these deposits are indeed remnants of Theia? Gravity anomalies, dense, heavy pockets of matter deep under the moon's surface, are the key to this cosmic puzzle. These anomalies aren't just random patches of dense material. They're telltale signs of a violent history, footprints left behind by a planet that no longer exists. When we talk about gravity anomalies, we're referring to variations in the moon's gravity field. These variations give us a unique opportunity to peer beneath the lunar surface and uncover what's hidden beneath. It's akin to using X-ray vision to see the bones inside a body, except in this case, the bones are ancient, dense deposits of titanium iron ore. A team of scientists led by planetary geophysicist Adrian Broquet from the German Aerospace Center in Berlin has been analyzing these gravity anomalies. The data they've been studying comes from NASA's Gravity Recovery and Interior Laboratory spacecraft, or GRAIL for short. GRAIL has detected two particularly dense regions beneath the moon's crust. These regions match the titanium and iron deposits that would exist if the Theia impact theory is correct. In other words, these gravity anomalies could very well be the remnants of Theia, buried deep within the moon's mantle. To further explore this theory, a separate research initiative led by Durham University has been conducting supercomputer simulations. These simulations recreate the massive collision that is believed to have occurred between Theia and Earth, some 4.5 billion years ago. These simulations help us understand the consequences of such a colossal impact. They paint a picture of fragments from Theia becoming embedded deep within the Earth's crust, and of molten lava pools of heavy titanium and iron sinking deeper towards the moon's core. The evidence points towards an ancient, catastrophic event that shaped our world and moon as we know them today. It's a dramatic tale of collision and transformation, of destruction and creation, written in the very fabric of our planet and its natural satellite. And it's a tale that continues to unravel as we probe deeper into the mysteries of gravity anomalies and Theia's legacy. So, what does the discovery of Theia's remains mean for us today? Well, it's like piecing together an enormous cosmic jigsaw puzzle. We've spent the last few minutes diving into the discovery of Theia's remains deep beneath Africa and the Pacific, and the compelling evidence supporting this. This discovery is a significant milestone in our understanding of the Earth and the Moon's formation. It's like finding a missing piece in an age-old puzzle, allowing us to see the bigger picture more clearly. Imagine a Mars-sized planet named Theia crashing into Earth around 4.5 billion years ago. The impact was so intense that Theia was reduced to hot lava fragments, some of which are believed to be buried as massive blobs deep underneath our planet's crust. Just think about it. Parts of another planet are buried deep within our own, highlighting the interconnectedness of our cosmic environment. But Theia's story doesn't stop there. The evidence from NASA's Gravity Recovery and Interior Laboratory spacecraft has found significant deposits of titanium iron ore deep beneath the moon's surface. This suggests that the rest of Theia's remains went on to form the very moon that orbits our planet. This discovery not only supports the long-theorized collision, but also offers a fascinating glimpse into the violent and chaotic history of our solar system. In essence, the discovery of Theia's remains helps us understand that our Earth and Moon are not isolated entities. They are products of a dynamic and interrelated cosmic history, shaped by cataclysms and rebirths. The story of Theia is a reminder of the complexity and mystery of our universe. It's a testament to the power of scientific discovery and a call to keep exploring, to keep asking questions, and to keep seeking answers. The discovery of Theia's remains deep within the Earth and Moon reminds us that our planet's story is part of a much larger cosmic tale, one that we are only beginning to understand.